Next is the another problem which is used to find out the reaction of the simply supported beam section. In this simply supported beam section, you can see this is a hinge and this is a roller, but roller is being elevated to an angle of 30 degree. Okay, so it is being elevated from like this to like this. It is being elevated for 30 degree, but reaction when you have to take it from this angle is given as 30 degree, but we have to take it horizontal with respect to the reaction. So that is this angle we need to find out. So in the roller here it is a 30 degree, but here the reaction it will be 90 degree here. So 30 plus 90 degree, it is 120 degree. Sum of interior is 180 degree. So 180 minus 120, it is 60 degree. Here it will be 60 degree. That means 60 degree here. This is equal to this angle. So that's why the angle will be 60 degree to this one. Okay, so we have simplified this 20 into 2 40 degree, sorry 40 kilonewton magnitude of the UDL converted into concentrated load. So 20 into 2, that is 40. It will be acting at the center, so that is 1 meter from this load. Okay, next is the triangular load. It will be acting at the 2/3 from this end and 1/3 from this end. So total length is 3 meter, 2/3 will be 2 meter. So half into base into height. So the load will be calculated as half into half. Base is 3 meter, the height is 10 meter. So it will be cancel. So it will become 5. 3 5s are 15. So load of 15 kilonewton will be acting at the 2 meter from this distance. So convert from the UDL to this 40 kilonewton, converting from a triangular load 40 kilonewton as 15 meter. Like this you have to do it. We know that the area of a triangle is half into base into height. The same formula you use it. Half into base into height you use it. So half, base is 3 meter, height is 10 meter. Use that. That will give the magnitude of the load as 15 kilonewton. So converting from a triangular load to concentrated load. So it will be acting 2/3 from this. It will be the whole load will be concentrated at 2/3 from this end. Okay. So the 2/3 is here. It will come exactly at 2 meter. So if you don't know how to do it, means what you do is 2/3. 2/3 into 3. So 3 will get cancelled. It will be acting at 2 meter from this end. Okay, that's what I have taken, 2 meter. So whatever the given beam section is been converted into a free body diagram like this. Now you go for the calculation part. Okay, so you need to find out the reaction at RA. So RA will be AX and AY and RB. Okay, that is been inclined to 60 degree. So what you do is you take a moment at A, okay. So then if you take a moment at A, take one by one. 40 into 2, it has been rotating. You take anti-clockwise direction as positive. Okay, 40 into 2, okay, that will be taken. So next 10 into 3, that is also taken. Okay, next 15 into 5, so 15 into 5. But here you be careful, this force has to be resolved into two forces. One is the horizontal force and another is the vertical force. This is RB, angle is here, RB cos theta, RB sine, this will be RB, angle will be like here, RB sine theta. Okay, so here when you taking, so this force will be acting here, this force will be acting here, so it will be go through this. So this RB cos theta will become 0. So don't take this one, you take only this one, RB sine theta. So RB sine theta is nothing but RB sine 60 degree. Angle is already known, it's a 60 degree. Directly you take it. Okay, RB sine 60 into distance of 6 meter. So 325 plus 1 6, so 6 meter. If you simplify this, then finally you will get RB is equal to 35.6. okay, then you will get RB value. Here only another two unknown is AX and AY. So you put the horizontal force, summation of horizontal forces is equal to 0. So one is this one, another is this one, RB cos 60 degree. So AX is moving towards right, you put it as positive. Okay, Ifx is equal to 0, Ax is positive, but Rb it is moving in left direction, so minus Rb 60. So Rb 60. Finally, if you calculate this one, Rb insert the value of 35.6 and finally find out the Ax value. Next, now we have determined the value of Ax and Rb value. Now only unknown thing is Ay, that is a vertical force. So what you do is you take summation of vertical forces is equal to 0, upward direction as positive. So upward direction as positive, you take it. Okay, upward direction positive. So you take it here, you can see here Ay upward minus 40, minus 10, minus 15, and this Rb it is moving upward, so positive. So plus Rb sine 60. That's what you put it here. After simplifying this, only unknown is Ay. Rb value we already determined, that is 35.6. insert it. Okay, so if you insert that, finally you will get the Ay. So here there is a two forces, Ax and Ay. For these two forces they will get another resultant force will be obtained. So this resultant force you have to determine. How? You take square root of Ax square and plus square root of Ax square plus square root of Ay. Okay, Ax square plus Ay square. Ax value already you have determined, Ay you already determined. Insert these two values, substitute these two values and find out the reaction at A. Okay, so that reaction at A finally you will get around 38.53 kilonewton. So now your reaction for the resultant force for the Ax and Ay you have determined, but resultant at what angle it will be acting, that you need to be determined. Okay, so that is tan theta is equal to vertical forces divided by horizontal force. So vertical force is Ay and horizontal force is Ax. So tan inverse of tan theta is equal to modulus of Ay divided by Ax. So you know Ay value, that is 34.17, and Ax value 17.82, 17.8. Both the values you substitute it and find out the theta value. The theta value is the resultant force with respect to horizontal. So finally, after finding this theta value, you will obtain around 62.48 kilo, so 68.48 degree. So that is the theta A angle here with respect to the resultant angle at the at a point A in the beam section.